Hey everyone, ready to dive into something pretty cool. We're talking MuJoCo. It's a physics engine that's being used everywhere, from robots and biomechanics stuff to those crazy realistic special effects you see in movies.
Yeah, and it's not just about how things look, right?
Yeah.
MuJoCo actually lets us simulate movement and interaction with this crazy level of realism and accuracy that we've never really had before.
Yeah.
So we're talking about a tool that's seriously changing the game for researchers, animators, anyone who wants to understand how stuff really works.
We've got all the details right here. We're going to jump into some excerpts from their GitHub page to get a quick overview, and we'll really dig into their official documentation. I'm ready to unlock the secrets of MuJoCo. How about you?
Let's do it. All right, so MuJoCo, it stands for multi-joint dynamics with contact, and it's tackling this huge challenge in simulations.
Which
Being able to accurately represent all those complicated joint movements like you'd find in a robot arm A and D, the realistic physics of how objects collide and interact all at the same time.
Oh, okay. So it's like the older robotic simulations were good at joints, and gaming engines, they nailed the whole visual thing with collisions, but MuJoCo figured out a way to bring those two worlds together.
Exactly. And that changes everything because now researchers can design and test robots, but with this crazy level of realism that just wasn't possible before. Imagine being able to try out different robot designs or control algorithms all in a virtual environment before you even build the actual thing. That's what we're talking about with MuJoCo.
Wow, that's wild. So it's like a virtual proving ground for robots, basically. But it's not just robots, right? The GitHub page mentioned it's used for biomechanics, animation, even machine learning. It seems like the possibilities are kind of endless.
They really are. And when you think about it, realistic simulation is important for so many different fields. I mean, with this, biomechanists can study how humans move, how to design better prosthetics. Animators can create characters that are crazy lifelike for movies and games.
Yeah.
And the machine learning applications, well, we'll get into that a bit later, but that's where things get really interesting.
Okay, you've definitely got my attention, but before we go too far, let's unpack some of the stuff that makes MuJoCo so special. The GitHub page mentions something called generalized coordinates and a unique approach to contact dynamics. To be honest, those sound a little intimidating.
I know, right? But I promise, they're not as scary as they sound. Think of generalized coordinates as a better way to describe how things move, especially for complex objects with lots of joints. So instead of tracking every single point in space, which would be super inefficient, we could just describe the movement in terms of joint angles.
So instead of saying, move this point 2 centimeters left and 5 centimeters up, we just say, bend the elbow 30 degrees, and MuJoCo just knows what to do.
Yeah, exactly. It's like we're speaking the language of movement, but in a way that makes sense, and that's way more efficient for computers to handle. And that efficient way of representing movement through generalized coordinates, that's what lets MuJoCo tackle these really complex contact dynamics calculations so accurately.
Okay, and contact dynamics, that's how objects actually interact when they collide, right? Not just bouncing off each other like billiard balls, but deforming, sliding, all that.
Yep. A lot of physics engines treat contact as just this series of instant collisions. But in reality, contact is a process. Imagine a tennis ball hitting the ground. It compresses first, right? Deforms, then it springs back into shape. So MuJoCo models that whole process, and it considers things like the material properties and forces involved. That's how it gets those crazy realistic simulations.
Wow, I never realized how much goes into simulating something as simple as a tennis ball bouncing. No wonder MuJoCo is used for so much robots, biomechanics. If it can handle that level of detail, it can handle basically anything.
Pretty much. And to really get what MuJoCo can do, we need to understand how it works, the elements that make up these simulations. The documentation actually gives us a really good starting point with a simple example. A box falling on a plane.
Okay, so we're going from tennis balls to falling boxes, huh? Seems basic enough, but I have a feeling there's more to this example than meets the eye, right?
Oh, absolutely. This simple example actually shows MuJoCo's main principles in action. It shows how we define objects, their properties, their initial conditions, and then we just let MuJoCo's physics engine take over to simulate the effects of gravity and contact and all that.
So it's like the hello world of MuJoCo simulations.
Exactly. It's the gateway to understanding how MuJoCo models the world. And from there, we can build more complex and really fascinating simulations.
All right, so let's break down this hello world example a little more and really see what makes MuJoCo tick. The documentation talks about things like bodies, joints, geoms. It's starting to sound like we're building a whole robot here.
It's a good way to think about it.
Hmm.
Imagine bodies as the core pieces of our simulation. They have properties like mass and shape, and they basically define the objects that are going to be interacting in our little virtual world.
Okay, so in our box falling on a plane example, we'd have two bodies, right? One for the box and one for the plane.
Exactly. Now, to give those bodies an actual look in our simulation, that's where geoms come in. Geoms define the shape, the size, the color, even things like texture.
So the GM determines if our box looks like, say, a cardboard box, or like a wooden crate, or even a stack of gold bars. It's all up to the GM.
You got it. That's what gives our simulations their visual style. But we're not just working with static objects, right? We want things to move, interact, and that's where joints come in.
So if we want to simulate, like, a robot arm picking up that box, we'd use joints to connect the different parts of the arm and let them move realistically.
Precisely. Joints are what really make our simulations come to life, and they let us create everything from like a simple hinge to a complex multi-axis robot arm.
Yeah.
And this is where MuJo's use of those generalized coordinates really makes a difference. Remember how we talked about representing movement in terms of joint angles? Well, MuJoCo uses those to control how the joints move with amazing accuracy and efficiency.
Okay, I think I'm starting to see how these pieces fit together. We have our basic building blocks, bodies for the objects, geoms for how they look, and joints to connect them and make them move. But what about things like sensors and actuators? Those sound a lot like parts of an actual robot.
And that's what's so cool about MuJoCo. It really blurs the lines between simulations and the real world. So sites, those are like virtual landmarks we can place on our bodies. They don't actually have a physical form themselves, but we can use them to attach sensors or like define points of contact.
So if we wanted to simulate, say, a sensor on the tip of that robot arm, we'd define a site at that spot.
Exactly. And then we can attach a virtual sensor to that site so we can collect data, just like we would with a real sensor. Like we could measure how strong the grip is, how close it is to other objects, even simulate a camera feed from that point.
Wow, that's incredible. It's like giving our simulations a whole new sense. What about actually controlling those movements, though? We talked about joints, but how do we get them to move how we want? That's where actuators come in, right?
Exactly. Actuators are how we apply forces and control movement in our simulations. They can represent things like motors, muscles, even external forces like gravity or wind. By carefully setting up our actuators and their properties, we can create these super realistic and complex movements.
So back to our robot arm, we could use actuators to simulate the motors that control each joint, and then we can basically program the arm to pick up and move that box however we want.
You got it. And just like with sensors, we have all sorts of different actuators we can use, each with its own properties that we could tweak to get the behavior we want.
This is amazing. It's like we're building this whole virtual puppet show, right? Complete with strings, motors, even sensors that tell us how our puppets are interacting. But instead of wood and cloth, we're using physics and code to make it all happen.
That's a great analogy. MuJoCo gives us these incredible tools to build and really explore these complex systems. And the best part is we're just scratching the surface of what we can do with it.
This is usually where my brain starts to feel a little overloaded, but you're explaining it all so well.
I'm glad to hear it. And trust me, the more you learn about MuJoCo, the more you realize just how powerful and versatile it is.
Okay, so we've got a good grasp on the basics. Bodies, geoms, joints, sites, actuators, sensors. What else is there to learn to really become fluent in MuJoCo? So we've got our toolbox, we build a basic simulation, but I'm still thinking about what you said earlier about MuJoCo and machine learning. How does a physics engine like this even work with something as complex as AI?
That's where things get really cool. Imagine like you're trying to teach a robot how to walk.
Okay.
In the real world, that's a ton of trial and error, right?
Right.
You could damage the robot, there are safety concerns.
Yeah.
But with MuJoCo, you can basically make a virtual copy of that robot and just let it loose in a simulated environment.
So instead of a physical robot like face planting on the floor, it's just tripping and falling in the simulation where it can't get hurt.
Exactly. But here's the thing. Because MuJoCo is so good at simulating real physics, all those virtual tumbles actually give us really valuable data.
Oh, I see.
Machine learning algorithms can look at all those simulated falls, they can find patterns, and then they can actually adjust the robot's movements to help it improve its balance and coordination.
So it's like robot boot camp, but without the bumps and bruises.
Yeah.
But we're not just talking about robots learning to walk, right? What other kind of AI stuff can we do with MuJoCo?
Oh, the possibilities are huge. Think about training. like a self-driving car algorithm. Instead of letting it loose on real streets and risking accidents, use MuJoCo to build this whole virtual city.
Oh, wow.
The AI can drive around this city a million times, it can encounter all these different traffic situations, and it learns how to respond safely and efficiently without putting anyone in danger.
That's incredible. It's like a virtual driver's ed for AI, where it can make all the mistakes it wants without any real-world consequences. But beyond robotics and self-driving cars, where else does MuJoCo fit into this whole AI and machine learning thing?
Honestly, think of any field where understanding complex interactions is important. Researchers are using MuJoCo to simulate things like how proteins fold for drug discovery, crowd dynamics for urban planning, even how diseases spread so we can develop better ways to stop them. Being able to create these realistic virtual environments is a total game changer for so many different fields.
It's kind of mind-blowing when you think about it, that a tool that started out simulating something as simple as a box falling on a plane could end up having such a huge impact. I mean, we've gone from robots taking their first steps to simulating entire cities and even understanding the tiniest building blocks of life itself.
It just shows you how connected everything is.
Right.
What might seem like a specialized tool can unlock all these crazy advancements in areas you wouldn't even expect. MuJoCo is a perfect example of that.
I have to say, this deep dive into MuJoCo has been amazing. We've covered so much ground, from the basics of how simulations work to the cutting edge of AI. It's clear that this physics engine is shaping the future in ways we're only beginning to grasp.
And that's what makes it so exciting. As more people discover MuJoCo and really start to explore what it can do, who knows what incredible things we'll see.
For anyone listening who's ready to start their own MuJoCo journey, be sure to check out the show notes. We'll have links to their GitHub page and all the documentation.
Go experiment, have fun, who knows? Maybe you'll be the one to create the next big simulation that changes everything.
And on that note, we'll wrap up this deep dive into the incredible world of MuJoCo. Don't forget to subscribe and join us next time when we'll explore another fascinating topic, uncover those hidden connections, and spark your curiosity. Until then, keep exploring, keep learning, and keep asking those what-if questions that push us all forward.